couple of things. I did some soul searching last night. Yes, I have a soul.
Oh my God.
Okay, it did not take long to search the soul because it is a tiny one. But I've been really frustrated and incredibly dissatisfied with the progress we are making with related rates. I hope last night's homework assignment went better. And that for the most part we are getting what's going on. That's my assumption. Okay, so I changed my plan, and that's rare because I make good plans and I stick to my good plans. The plan originally was that we were going to have a test on Unit 4 Friday. I changed that plan. It's going to be tomorrow. No, I'm sorry. Sorry, that's not what the plan was. Sorry, I got confused. And he was like, "Oh my God, he changed it." The test is going to be Monday. Now I say this with caution because Mr. Harper and I have talked about this. I never test on Monday. Ever do I test on Monday? Because people make stupid choices over the weekend like they forget to study. And they come in on Monday and they I am not willing to test on Tuesday. If we're not testing Friday, that means we are testing Monday. That means that there's an assumption that you are studying this weekend. You are getting yourself ready, because this is the only test in the whole unit, the whole 6 weeks. We have got to get this right. You are not ready to test on Friday, Andy. We're not. Based on the last 2 days, we're not. So I need you guys to know that the test has been moved to Monday. Tomorrow, there's going to be a quiz, a 30-minute quiz, for you to show me where you are, for me to understand where you are and your understanding of related rates, as well as implicit differentiation. Implicit differentiation is what we were doing right before Thanksgiving break. The X's and the Y's mixed together on the same side. You guys were doing well. Those are the two things you're being assessed on tomorrow. Other thing, those of you that got a parent letter from me on Monday, I said it is due today. It's today. Please put it in the middle of the table and I will pick that up. If you don't have it for me today, I'm about to go circus boy crazy on your bahunkus, and it might even be public. So brace yourself. Okay, tonight's homework. Please make sure you write this one down. It's a little complicated. Okay, this is meant to be good review and preparation for tomorrow's quiz. You're going to do pages 83 to 87. It sounds horrible. It's not. It's only 1, 2, 3, 4, 7 multiple choice questions. 5, 6, 8, 9, 10, 18, and 19. 7 multiple choice questions. And then on page 88, question 2, 1 free response question. That is approximately the length of tomorrow's quiz. This covers implicit differentiation and includes related rates. And there's a free response question to make sure that you're really set up for excellence. Chris?
Are you going to send the solutions?
Am I going to send the solutions? No. You're going to work on that tonight. Tomorrow, as soon as you come in, the solutions will be in the middle of the table, and we'll have 20 minutes to go over it, ask questions, make sure you're ready. I am really trying to set you guys up for success here. And lastly, if you are dissatisfied with your quiz grade from before the Thanksgiving break, tomorrow at the end of lunch is your last opportunity to turn this in and have that grade changed. After that, locked in forever. That was the one on mean value theorem, L'Hopital, extreme value theorem, and
Turn into quiz corrections?
the quiz corrections are due at the end of lunch tomorrow. Henry?
After 9, it's 10.
After 9 is 10, yes. And then 18 and 19.
Yeah, okay.
Yeah. I was very confused, Henry. Usually you ask good questions. That wasn't your best. All right. Eval.
Are the corrections for anybody?
Are the corrections for anybody? Like, are you eligible to do corrections? Yes, even you, Eval. Even Eval can do corrections if you would like to. Your grade only changes if your test grade is higher. Everybody good?
Yeah.
Okay, good. All right, you've got 5 minutes. You're going to make this quick to compare the work you did on the homework last night to my solutions. The solutions are in the middle of the table. 19. Fine. I'm done. Okay. And on question number 1, I made a mistake. Rebecca needs to know. Rebecca needs you all to know. It's not square root of 1,725. It's square root of 1,825. You got 5 minutes. Use them wisely. Yes, ma'am. No, it's okay. Just 1, 2, and 3. Grab a marker. Yep, thank you. Give yourself some feedback. If you made a mistake, fix it.
So what's I'm doing it right.
What solution?
You want to stay on the same thing.
For great, bro.
Yeah, but
Feedback on these. If you made a mistake, fix it with the marker though. Yeah, I've heard that. That's what she said, and that's what I said. Don't listen. Begging for more proof. Yes.
I thought the X was about like. Why would the X be part of the A?
Well, okay, first of all, it's just a choice of letters. Okay, you are always 100 feet from where the balloon is released. So that's not a variable, that's going to be a constant. The height of the balloon is changing, right, because it's going up. So I labeled that as X because I didn't need X here. This is always X.
They make you.
Yeah.
When it came to doing this, you didn't use 50 because this one's changing 50 times 10, right?
They never told them.
Yes.
Oh, man. Acres.
The version that says like
Okay. Okay. I'm with you. Okay, so you're probably off by like 6 feet, 5 feet, or whatever. I'll just put a little touch mark next to it. I'll take it. And all right, last thing. Somebody turned in this beautiful homework assignment on implicit differentiation the other day. Didn't bother to put their name on it. I'm just gonna go leave it over here in my special file cabinet, so that in case you realize that it's yours, you should let me know. It's over there in the file cabinet. I realize that may be the wrong word. It may not actually be a file cabinet, but it's over. Oh, it might be Diego's. All right. So at this point, if you guys could just put your homework in the middle of the table. Hopefully it went well, went better. We're figuring out what's going on in the world of related rates.
Yeah.
Okay, good. You're going to show me how much you figured out tomorrow on the quiz. Today, I've only got 20 minutes, and I want to push your thinking a little bit more.
Yeah.
Yeah, thanks for being there for me, Henry.
Yeah.
So okay, you can stop sucking up now. Okay, in the unit guide on page 50. Yes, I said 50. 50. Okay. I have a problem that I think is going to rock your world more than a little bit, and you're going to be okay. Homework's in the middle of the table. I'll pick that up in a little bit. What I want you to do on page 50, take a minute, take 2 minutes, read through this problem, Mark it up. What are the things that you know? What's your plan of attack? This would be fair game on tomorrow's Quizzy Poo. Thank you. And home power here.
Isn't it 1/3? 1/3 times pi r.
That's what Shannon said.
Pi r squared.
All right. Water's flowing into a cone at a rate of 2 cubic centimeters per minute. Height of the cone is 16 and the radius of the cone is 4. How fast is the water level rising when there are 5 centimeters of water in the cone? Water is flowing into a cone at a rate of 2 cubic centimeters per minute. What is the calculus here? What is that? It's a rate, but it's water's flowing into a cone at a rate of 2 cubic centimeters per minute. This is a change in something, right? It's d something dt. What does it have to be? It has to be volume. If you look at the units, it's screaming volume. 2 cubic centimeters per minute. Positive or negative? It has to be positive because water is going into the cone. Okay, good. The height of the cone is 16 centimeters and the radius is 4. Is that always true? Sometimes true?
Sometimes.
Read that one more time.
Of the cone.
The height of the cone is 16 centimeters and the radius is 4. Is this an always true or like in the moment kind of true? Always. Because what you're talking about is the cone. The cone, like this guy here, the height is 16 and the radius is going to be 4. That's always true. Okay? When and the radius of the cone is 4, how fast is the water level rising when there are 5 centimeters of water in the cone? How fast is the water level rising? Like, here's your water level. If I'm pouring water into the cone, I hope everybody's okay with what's going to happen in this water level. Water level is going to go up, it's going to rise. So if it's going to rise at a rate, how fast is the water level rising? What I'm after is dHdt. This is what I'm trying to find. I'm trying to find dHdt when there are 5 centimeters of water in the cone. And I should have been more specific when the height of the water in the cone. I'll have to fix it in the handout. The height of the water in the cone is 5 centimeters, so the height equals 5 centimeters. The height's not always going to be 5 centimeters. There is this instant in time when the height is 5 centimeters. All the friends mostly okay?
Yes, sir.
Now here's the thing. I gave you dV dt. I'm asking for dH dt. What you need is a relationship that's going to link everything together. The ones we've done so far have been obvious. Pythagorean theorem, area of a circle, some right triangle trig. Is there some relationship for the cone that links everything together? Julissa, what do you think? Okay, volume of a cone. If you remember what the volume of a cone is, I'm going to be way impressed. Volume of a cone is
1/3.
1/3.
Pi r squared inside.
You all are telling me that with all the struggles we've had this week in geometry, your class is the one that remembers how to find volume of a cone.
Yeah.
We couldn't remember the Pythagorean theorem. SOHCAHTOA was confusing. Area of a circle, no. volume of a cone, you all somehow remember volume of a cone. I'll let Mr. Dawson know he was doing a really good job that day. He was on fleek.
I think I should talk to him.
Okay, I should talk about ice cream.
We used to talk about it when he did his training.
Okay. Interesting to know that class of 2018, volume of a cone, that's your thing. Good. So here's the thing. You know dVdt, you want dHdt. What are we going to do? We're going to find the derivative. And if you're going to find the derivative, you're going to have to be way careful. Way careful. What derivative rule here?
Product and exponential.
So the 1/3 and the pi, these are constants. So maybe not too terribly worried about that. But the r squared and the h, you are going to have to multiply these guys together. This is a product rule. So take a minute and see what you can do. If you can find this derivative, that's like a 2 or 3 point derivative. Marilyn and Henry. But if you're multiplying by a constant, you ignore the constants and you focus on the other part. Right, the derivative of 5x squared is 5 times the derivative of x squared.
B 2r and h plus r squared and
Oh wait, I didn't put that.
But she's saying that we should like
All right, friends, let's put this together. Volume is 1/3 pi r squared h. So take the derivative with respect to time. Has to be dV/dt. Has to be dV/dt. The 1/3 pi, I'm just going to ignore it. It's a constant that I'm multiplying by. The real action comes in with finding the derivative of r squared h. And I heard product rule earlier. Well, if I'm going to use the product rule, that means we take the derivative of the r squared. Not 2r.
Oh,
2r times dr dt, because the radius is changing with respect to time. As water goes into the cone, that water bubble goes up, the radius gets bigger. Oh, just turn that off. So 2r dr dt is the derivative of the first times the second plus r squared times 1 dH dt. And I heard a couple of folks mumbling at me, wait, you're going to blow it, there's something that you need to do here. You need parentheses. That 1/3 pi has to multiply all of this stuff here. If you can get that derivative, that's probably worth 2 points. Henry?
But if it's a constant, why do we bring it down?
See, it's the same conversation that we keep having about, is that constant something you're multiplying by or something that you're adding?
Oh.
If you're multiplying by a constant, what happens is you say, well, let me ignore the constant. What's the derivative of x squared? 2x. And then what happens? You multiply by the constant. Down here, when you're adding a constant, you say, let me find the derivative plus the derivative of the constant is 0. Are you adding the constant or are you multiplying the constant? You're multiplying, so we just leave that constant alone. Everybody okay? Okay.
Wait, so if it was 1/3 pi plus 2, you would
There you go.
take
If this was if somehow you remember this as 1/3 pi plus r squared h, that's a constant that you're adding. The derivative of a constant becomes 0. All the friends are good?
Yes.
Okay, I'm about to blow your minds now. If you're like, no, you're good. I want dH dt. If we're going to find dH dt, that means you know everything else. Right? I want dH dt. What do we know?
It's 5.
We know h is 5. Good, I can plug 5 in there. I know dV/dt. Good, I could plug in there. Sadly, you don't know what the radius is. You don't know what dr dt is. And then obviously, if you don't know the radius, you don't know what r squared is.
The we know is 4.
We know that.
The radius is 4?
No.
That's for the cone. Not for this guy down here. That's the radius for the cone. Pretty kind of okay. Here's the part that you would not see coming. Sometimes there are hidden relationships. And this is going to push your geometry thinking some more. The obvious relationship was that the volume is 1/3 pi r squared h. You guys seem to snap to that pretty quickly. Good news, I would give you that formula in the middle of a test. I would not expect you to memorize it. College Board doesn't either. But this is the obvious relationship that you can take the derivative of. There's a hidden relationship that has to do with similar triangles. Does anybody see similar triangles? Not on my face. Rebecca, where? There are similar triangles here. There's this one, and then there's this guy in here. And now what that means is you can actually set up another relationship. For the small triangle, this guy is H, and that's R. For the big triangle, what do we got? We've got 16, and we've got 4. Because they are similar triangles, they are proportional. Let me say that again. Because they're similar, they're proportional, meaning I can set up a ratio. I can say something like, if I compare the height of the small to the radius of the small, that has to be equal to the height of the big one to the radius of the big one. You could divide everything by 4 and say that h divided by r is equal to 4. Always true or sometimes true? Always true. Right, no matter what happens, no matter how high the water goes, I'm going to have these similar triangles. If this is always true, guess what? If this is always true, you can find the derivative here. Just like you can find the derivative of the volume, because this relationship was always true, this relationship is always true. We can find a derivative here. Now what I want to do, I want to make sure you guys are okay with this, because I'm still a big fraction killer. If h divided by r is equal to 4, that means that the height is 4 times the radius. The height is always going to be 4 times the radius. So what happens with the derivative? If the height is 4 times the radius, then dh dt is equal to 4 times dr dt. We started with the proportional relationship, which was the sneak attack. I don't think anybody saw that coming. I rewrote it so to say that the height is 4 times the radius. And as soon as you do that, now you can take the derivative on both sides, because this is always true, so this guy's always true. I would put a star next to this because this is the sneaky part that I don't think you guys saw coming. Now look what we're trying to do. I want to figure out what dh dt is. They gave me dv dt. They gave me, did they give me something else? No, they didn't give me anything else, did they?
dr.
They gave me dr dt?
No.
They didn't give me dr dt.
So can't you just plug that in?
But we know that dh dt is 4 times dr dt, is what I hear Sylvia saying.
So you can study.
So if dh dt is equal to 4 times dr dt, how about plugging that in there for dh dt? Do we know the radius?
No.
We don't know the radius, but you know the height.
So we're solving for dr dt.
Really, we want dh dt.
Oh.
We want dh dt. You need the radius, but what I did is I gave you the height. And you have a relationship that's always true. The height is 4 times the radius. So if the height is 4 times the radius, at this moment when the height's equal to 5 centimeters, so I could say something like, since the height is 4 times the radius, that means that when h equals 5, 5 is equal to 4r, so r equals 5/4. So look at where we are now. We knew dV/dt. We've got the 1/3 pi. 2 times, we know what the radius is now. We know what the height is. I don't know dr/dt, which is a little sad. But we found a way to rewrite dh/dt in terms of dr/dt. Let's just plug it all in and see what happens. dV/dt is 2. You've got 1/3 pi. 2 times your radius is 5/4. dr/dt, we don't know. The height we do know, right? What's the height? Is that 5?
Yeah.
Plus your radius squared, 5/4, the whole thing squared, times dh/dt, which we're going to replace with 4 times dr/dt. I realize that looks ugly. Hold on, Korean. But take it all in for a second. Even though it's ugly, how many variables? One. There's one variable in this equation. You should be able to solve this for your variable. You just got to do a little bit of fancy footwork here. So 2 times 5/4 is that 10/4, 5/2 times 5. I've got 2 equals 1/3 pi times 25/2 dr/dt. Plus 5/4 squared, 5/4 times 5/4, 25/16 times 4 is 25/4 dr/dt. Your goal is to solve for dr/dt. That's the goal. Maybe you want to get rid of the 1/3 pi. Lots of options here. Okay, you could distribute everything through. You could factor out the dr/dt if you want to. Just lots of ways you could approach this. I'm going to multiply this through. 1/3 pi times 25/2, I think, is 25 pi over 6 dr/dt. 1/3 pi times 25/4 is 25 pi over 12 dr/dt. Your goal is to solve for dr/dt. I realize some of us are probably starting to trip over the fractions. And my advice to you all with the fractions,
Rather than none.
kill them off. Find the common denominator. What's that common denominator?
6.
Whoa.
2.
Sometimes Henry's too loud for his own good. 12. Multiply everything through by 12. 12 times 2, 24. 12 times 25 pi over 6. You could go the painful way and say 12 times 25 is 300 and divide by 6. Or how about 12 divided by 6 is 2? And you're going to get 50 pi dr/dt plus multiply through by 12. 25 pi dr/dt. We're almost there. We're almost there, almost there, almost there.
You get 75 5 times.
This is really 75 pi. So we go over here. So 24 equals 75 pi times dr/dt. We're going to divide by 75 pi. dr/dt equals 24 divided by 75 pi, or if you want to show off for all the friends, 8 divided by 25 pi. And here's my fear. You're going to get so excited. You're like, I'm done, I'm done, I'm done, I'm done, I'm done. Rebecca, why are we not going to be super excited here? What you have found is dr/dt. What I need is dh/dt. Chris was really excited. He's like, I'm done. No.
You can plug it in and solve it.
So what's dh/dt?
4 times dr/dt.
dh/dt, if you believe that relationship over there, it's just 4 times what you found over here. 8 over 25 pi, which is the same as 32 over 25 pi. And I need units, dh/dt. H we're measuring in centimeters. not cube, height. We're looking at height. Time we're measuring in minutes? Yep, minutes. That's DHCT, and that was rough. In the world of related rates, that's about as rough as it's going to get. Unless maybe I come up with something harder for tomorrow's quiz. Karina, the Devo.
For radius, how come?
Sorry, Gonzalo. Karina, what's up?
For radius, how come you only use like, how come you didn't use 16?
For the radius, why didn't you use 16? Because 16 is the height, not the radius.
I mean 4.
Why didn't I use 4 for the radius? Because 4 is the radius for the cone, not the radius for where the water is. Okay, here's what I care about. I want to make sure we're all on the same page. Was everybody okay sort of deciphering the information from the word problem? We're getting better at this. Either you knew what the formula was, or I would give you the formula. And as soon as you recognize that this is true, finding the derivative, maybe not too bad. I think the algebra and like the number stuff got a little bit ugly, but I think we're getting much better with the calculus side of things, which is good. Okay, 2 nights homework, you guys already know it's page 83 to 87, 5, 6, 8, 9, 10, 18, 19. Those are multiple choice questions that involve related rates and implicit differentiation, and 1 free response question, which is question number 2. And that sort of ends scene, because with 30 seconds, we're not going to start a new related rates questions. But don't pack up yet, because that makes me look like a bad teacher. So maybe have like a deep conversation with somebody near you. Maybe that conversation is like, I finally get it. Excellent. I'm learning. Oh, no.
On average, yearly. What take you the most? If you win the lottery, everyone say you won the lottery on like all your like minutes. Like these won the lottery, take the money. I mean, you can say the higher the better the lottery. Wendy, you've been looking good.